The multimodal tongue drive system is a device to help people with tetraplegia to drive a wheelchair using their tongue and head movements. In this video, we will demonstrate how to use the device using 4 different modalities. First, as preparation, a tiny magnet is attached to the tongue tip of the user. Then the user wears the headset, which has magnetometers, accelerometers, and gyroscope to capture both the gestures. A touchscreen-based user interface is designed to check the device functionality, calibrate, and train the gestures. During the calibration, the user needs to move the head up, down, and circle while keeping the magnet in the resting position. Calibration quality can be checked by going to each waveform of the sensors by selecting the drop-down menu. While training, each tongue command is trained by holding the magnet to a specific tooth and clicking the collect button. Once done collecting all tongue commands, the train button is clicked to train the machine learning algorithm. Finally, the model files are transferred by clicking transfer button. During the testing, the tongue and head gestures are assigned to see in the display whether they are working properly or not. Now the device is ready to drive the wheelchair using both head and tongue. The driving menu can be opened by clicking the PWC button of the main window. After that, the wheelchair is powered on. Here, we have selected the tongue lashed mode to drive the wheelchair. In this mode, the wheelchair can be lashed using left select tongue command and unlashed using the right select command. While lashed, the chair can be turned left or right direction. While unlatched, the wheelchair can also be moved in left, right, forward, or backward direction by selecting left, right, up, or down tongue commands. The next mode of wheelchair driving is using only head movements. In this mode, the wheelchair can be moved forward or backward direction by tilting the head forward or backward. In order to turn left or right, the user has to rotate the head left or right. The minimum threshold movement to move the wheelchair for each direction can be configured using the user interface. In this mode, both the forward left or right command can be assigned by tilting the head forward with a left or right head rotation. The wheelchair can be moved similarly by tilting the head backward. The next mode combines both the tongue and head movements to drive the wheelchair. Tongue commands are used to latch, unlatch, and move the wheelchair forward or backward direction by using left select, right select, up, or down tongue commands. To turn the wheelchair left or right, the user has to rotate the head left or right direction. This driving technique emulates similar to driving a car. Here, the tongue commands are used as a gas pedal and head movements as steering. Left select and right select tongue commands to turn on or off the cruise control driving. Some people with tetraplegia may have limited head rotation ability due to their injury. For them, another tongue and head combined gestures-based driving mode is introduced. Here the user moves forward using a forward head tilt and backward by backward head tilt. The cruise control or lashed mode of driving can be activated by tilting head forward above a threshold. To turn the wheelchair left or right, the user only needs to use left or right tongue commands. In this way, the user does not need to rotate the head frequently to turn the wheelchair in case of limited head movement ability. Cruise control can be turned off or unlatched using a left head rotation. The same device is used to access a computer by adding speech recognition to the tongue and head gestures. Tongue motion can be used to navigate through items in a computer by mapping tongue commands to the 4 keyboard's arrow keys. Head tracking can be used to move a mouse cursor, while tongue commands can be reserved to emulate mouse clicks. In this game, both of these modalities are used simultaneously, with head tracking aiming the arrow and tongue commands to shoot the bubble. Head tracking and tongue commands can also be used alongside to open a file and scroll through it.
Wake up. Open Google Chrome.
More complex tasks can be performed by combining all modalities simultaneously, including speech recognition. For instance, a browser can be opened with voice commands, while mouse cursor can be controlled by head tracking and mouse clicks emulated by tongue commands. Thank you for watching this demonstration video. This work is done in Georgia Institute of Technology in collaboration with Brooks Rehabilitation Clinical Research Center.